I am Anna Mundet. I'm from Sant Cugat. I'm a technical maintenance of Sant Cugat City Council, and I present you with a few slides the Sant Cugat pilot. We divide this presentation in 3 parts. Oh, sorry, Antonio, I have a problem. Yeah. Oh. Now it's good. In 3 parts. What was before the project? We do it some intervention before the project, the GEOFIT project. The second part is the GEOFIT project, and the last one is conclusion or summary, or what is what conclusion of the GEOFIT project. What was there? GEOFIT in Sant Cugat pilot is a school and a tertiary building. Is education. Is located in Sant Cugat, near to Barcelona, not far away to Barcelona. And so the climate condition is Mediterranean. The building is, as you said here, is integrated with 4 buildings. One is kindergarten, that is outside in this project, and these 3 is a pavilion, a sportive pavilion, administrative building, and primary school. This building is around 400 square meters. It's a little bit big for us. These are with a central heating system, a boiler gas system here, and total energy is about 16% of gas natural, and the rest is electricity. Electricity is LED, lights, computers, and so on. What was existing over there is 3 boilers, standard boilers, and also cast iron radiation in this school. And also in cooling system, there is no cooling system in the building, only in the computer classrooms, 4 splits. And also in the pavilion, sport pavilion, there is aerothermal that produce heating and cooling also. Before the GEOFIT project, we did the installation PV panels, and also we changed the lamps with LED technology, and also we retrofitted the facade, external thermal installation. These 3 implementation, we do it before the project. That is really important for us because we want to demonstrate that with a GEOFIT project, we reduce a lot of energy in this school. And then the power of heating and cooling is about 63 kilowatts, and cooling for these splits and so on is about 12 kilowatts. I show you some picture for solar thermal, and then the photovoltaic integrate in the building, in the primary building. Also some picture for the facade retrofitting in these 3 buildings, in the administrative buildings, primary buildings, and we show you the result was really good for the school. We reduced a lot of energy, gas energy. And then the situation of the school. The situation of the school is really good for this project, for the GEOFIT project, because it is a green area with a lot of superficie. Oh, sorry. With playground, that is also possible for drilling in this area. I'll show you later, and it's really good for to do drilling in this area. Okay. Now the GEOFIT project. The GEOFIT project, I explain in 4 or 5 steps or phase. One first is design. The most important in this project for us is design very good the project, then the project and the permissions, and then the installation, BMS, and commissioning, the last one. The design is really important because we have a lot of partners who participate in this project. For example, in simulation demand modeling was doing with KTH and Uponor. They simulate how to produce the GEOFIT system with heating and cooling and peak load and on total load. And then the drilling excavation is doing with Catalana de Perforaciones. They estimate that we do it 12 boreholes with 100 and, well, this is not correct, 120 deep, meters of deep, and space between these boreholes 10 meters, and one horizontal drilling. Then the other one is CIART, that doing the building monitoring during the drilling phase, like also in Perugia, like Perugia say. We're doing before the perforation, during the perforation, after the perforation, what's happened with the building, if it's move or not move, and nothing happened. What is really good for us, because we don't know if something happened with these boreholes. And also the heat pump is doing with 88 and Oshno. It's an electricity heat pump with 40 kilowatts heating capacity, and also the buffer tank, and the refrigerant is R1234 ZEE, and also the control operation in this heat pump. The other thing is all other partners who participate in this project is Oceanar, Ileco, and COMSA with an operation strategic. Before this project, COMSA and Ileco pre-monitoring this building, and then we doing also the monitoring on the strategic for the commissioning. We co-generation the heat pump with the boilers, and then the boilers, the heat pump will be cover most of the heat pump, and then it is not possible to, if we have a lot of demand, we put the gas boiler on. And BMS and BEMS was done with Ileco and COMSA. The BES on the top, because BMS is existing in this building, is doing with Trend, with our maintenance enterprise, is integrate this geothermal system in this Trend, and then we do it the BEMS to control operation mode based on efficiency, demand, response, and flexibility. After this, we clear that we have all the instruments, all the things, and we do it the piping and instrument diagram. This is the boreholes. We connect with the heat pump, and then connect to the tank, and this tank is also connect with the boilers. It exists in the building, and then go to the school or the pavilion or the another building. Is also here another installation that is passive cooling that I will speak later, but it is the diagram, the final diagram that we have in Sant Cugat. With this diagram, we do it the project. In Sant Cugat is a municipal city council, and it's necessary to have a legal permissions. One, and important, is our permission, internal permission, to approve this project. And then also the Catalan administration have permissions. One is of Department of Energy, Industrial Safety and Mines, that we have a permission, and also the Catalan Water Agency, we have another permission. With these three permissions, we can start to do this installation. We start the first year. We start with test investigation boreholes. In Catalan it's TRT, I don't know in English, sorry. We do it with Catalana de Perforacions, and we show you the evolution of temperatures, and the result was that the temperature of the ground is about 16 degrees. That's great, but the simulation of Uponor and KT8 was the same, and we continue for the installation. Next year, we do it the boreholes. The boreholes, this is the technical room, and the boreholes are not far away, but in the playground next to the building. We do it, this point are the boreholes. We connect with the line with the collector. This is the collector that go with one only, we connect with the technical room. This is also the collector with, with lines of boreholes. This is blind boreholes. This is a one boreholes and the collector. And the next year, we have some problems with the pandemic because the heat pump didn't arrive at the same time of the boreholes. We do it the next year because it's really difficult for us. This is the piping and instrument diagram that I showed you before. This is the boreholes. We connect with the technical room. We connect with the heat pump behind the heat pump. This is heat pump. And then, this is the boreholes that we connect here. Sorry. I have some problems with internet, sorry. Okay, sorry. With the boreholes, we connect with the heat pump. This is the heat pump, in front of the heat pump. And next to the heat pump, we connect to the tank. This is the tank. And then connect to the existing systems. We change the valves. This is we have the valves obsolete and not integrated with the BMS. We change it for the limo valves that are administered by the limo. This is the limo valves, and control all the energy and fluid also. And then the third part is the BMS installation. This is the final diagram of BMS. This is the LECO. On cloud of this LECO is connected with the electric meters, gas meters, and so on. And then to connect to the installation, GEOFIT, geothermal installation, the geothermal boilers, tank, and also the 4 limos valves, and also integrate the photovoltaic installation that was done in the past. We connected all with one BMS. That is really important for us because we control all the energy in this building. This is another architect of installation. It is very important to show you that BEMS, we connect with all the meters and also all the parameters on this installation. And there is another thing that we also do passive cooling in administrative building. Is one thing that I think is very important to retrofit this building because it's really hot in summer. This is the blowholes who directly send the hot water in the building, and then with the retrofitting building is better. And then the last part is the commissioning. The commissioning was possible thanks to the participant of this project. We do it in one day, more or less, because we clear all the fuss in this project. The BMS was done, the hydraulic system was done, all the things was done, and then the commissioning was possible. This is the result. The result is the boreholes are here, the heat pump are here, the tank are here, the gas boiler are here, but all the elements are controlling in this BMS. This is really good to show that this installation is possible. It's also possible and reduce the energy. We also control sorry. We also control the schedule of this installation because it is a school and on Sunday is closed. We close the installation. We also control the temperatures, the elements necessary to reduce the energy, and the result is, well, the most important is we want and we hope that we reduce the energy about 60% with all the building, not only GEOFIT thermal, with also the retrofitting buildings. And our conclusion, this is the first geothermal installation that we do in Sant Cugat, in municipal building. That is, it's really important for us because we don't know if it's possible to do this or if it's expensive, or I don't know. Well, a lot of people talk about the thermal things or installation and so on. And now what our experience is that we want to replicate in all the buildings. But the thing is, cooperate is the most important thing in this project, because without partners, it was not possible to do it. Also, the BMS is integration is really important, because if we don't control the installation, it's not possible. And that's all. That's my presentation. Thank you for listening.